Everyone, and today I'm going to look at chapter 3, parallel and perpendicular lines. So let's start by looking at two lines that are parallel. Now, what you can say for sure is that when two lines are parallel, their slopes are equal. So parallel lines have the property that their slopes are equal. So I'll call that M1 and M2. So all you need to do is to find the slope of each line. And if that slope is the same value, then you are looking at parallel lines. Now, the other kind of lines are called perpendicular lines. Now, a little bit trickier. Can you imagine this is my first line, M1. And let's say its slope is 3/2. And if you want to do a line that's perpendicular, let's say this line here, call this line M2, its slope could be -2/3. Now, when two lines are perpendicular, it means they cross at 90 degrees, as this one does, this pair does. So what is the property? How do we check if two lines are perpendicular or not? Because really, can two lines cross all sorts of angles? Well, the property is rather surprising. But if the product is -1, then the two lines are perpendicular. So if you know the slope of this one and you know the slope of that one and you multiply the two together and the answer is -1, you can be sure that these two lines are going to be perpendicular to each other. Now, there is one exception to that rule. It's pretty straightforward. If you have a line that's vertical, then its slope will be 0. You know, if it's like parallel to the y-axis. And if your other line is horizontal, like that guy, going that way, then its slope is undefined. So if one line is vertical and the other line is horizontal, then actually the slope's the wrong way around there. 0 for horizontal and undefined for vertical. If you get a horizontal meeting with a vertical, they are also going to be perpendicular. So that's what we're going to look at first, which is questions that say, here is a line, here is its slope. Give me the slope of line that's parallel to it, or give me the slope of line that is perpendicular to it. So suppose I have a line, y equals 2/5 x plus 3. And I ask you for the slope of a line that's parallel to this one. And then I ask you to find, say, the slope of a line that's perpendicular to this line here. How do we solve that? Well, you're not given directly the slope, but we know how to get the slope. When a line is written as y equals a multiple of x plus 3, the slope is the coefficient of x. So the slope of this line is 2/5. So if you want to find the slope of a line that's parallel to that, you just find a line, any line will do, whose slope is also 2/5. Now, to get the perpendicular, that's a little bit trickier. So let's call this one M1. Then M1 times the other line, let's call it slope M2, has to equal -1. And I know that this one is 2/5. And so I'm trying to essentially find what the slope of this second line would have to be, so that when you multiply these guys, you get -1. Now I can tell you what the answer to that is going to be. It's going to be that. And so that would be our answer. The slope of a line that's perpendicular to this guy here is -5/2. Now you may say, well, how can you go from here to decide that this is answer? There are a couple of ways I could do it. One of them is simply to do some pretty simple algebra. 2/5 times M2 is -1. If I want to find out what M2 is, then I divide both sides by 2/5. And we know that dividing by 2/5 is the same as multiplying by its reciprocal. And that guy times its reciprocal is -5/2. So there's how I would do it. So far, so good, I hope. So let's look at, by the way, that question I just did is very similar to question 2. Let's say another situation. There's quite a lot of questions that say, here are two lines. Are they perpendicular? Yes or no. Or are they parallel? Yes or no. So suppose I give you a line and I tell you that the first one has a slope of 4/3 and the second line has a slope of -3/4. And I asked you, are these two lines perpendicular? Well, all you would do is multiply the two slopes together. In this case, 4/3 times -3/4. And if you do that, and you can do it in your calculator, you get -1. And the test is quite simple. If those two are in fact -1, you are looking at, yes, they are perpendicular. Now, if I'd asked you, are these two lines parallel, you wouldn't need to do any working. You could just look and say, they're not the same, so they can't be parallel. So you would have said no in that second circumstance. Suppose I gave you the equation of two lines, something like question 4. And I told you that the first line was -4x plus 2/3. And the second line was -4x plus 3. And I asked you, are they parallel? Right. Well, I can tell you just by looking that the slope of this line is -4. And I can look at this one and tell that the slope is -4. These are clearly equal. So the answer is yes, they are parallel. Now, they could make your life a little bit more awkward by giving you the equations of two lines and asking, are they parallel or are they perpendicular? But instead of giving you in the y equals format, they give you in the standard form. So an example of that might be question 5. So we have 5x take away 3y is 6. And the other one is 5x plus 3y is -6. Well, I need to find what this equation looks like when I rewrite it as y equals. So start with the left-hand side one. As long as you do it to both sides, it's a OK rule. So I'm going to subtract 5x from both sides. I'm then going to divide both sides by -3. That -5 over -3 gets me +5/3 x. And that guy times that guy gets me -2. So I now know the slope of this line is 5/3, so I'm halfway there. If we take this one, we get a 3y, subtract 5x from both sides. We get, divide everybody by 3, and I get -5/3 x minus 2, and the slope of this one is -5/3. And we're being asked, are they parallel? Now you have to be really very careful that slope is 5/3, and that one is negative 5/3. They are not identical. I know they're both 5/3, but this is positive and that is negative, so they don't count as being equal. So the answer for this one is no, they are not parallel. So let's move on now to the same types of questions, but this time the information that they give us is going to be a little bit different. We're going to find out, are two lines parallel or perpendicular? And we're going to be not told the equation of the line. We're not even going to be told the slopes of the line. All we're going to be given are the coordinates of 2 points that make the line. So here's a version of question 7. Now the first point is called that, and the second point is called that. So I want you to imagine that we find the line that's joining these 2 points. And all I'm really interested in is the slope of the line joining these 2 points. Now, I find it helpful if we call this guy P1 and we call this point P2. And there is an equation that you can use to find the slope of a line joining 2 points. And the formula for it is m, the slope, is y2 take away y1 all over x2 take away x1. And we call this guy x1 and this guy y1 and this fella here x2 and this guy here y2. So we now have 11 take away -1 and 2 take away 4. And 11 add 1 gets me 12, and 2 take away 4 gets me -2. So the slope of this line is going to be -6, and I'll call this one M1. And then I read a bit further, and they tell me 2 more points for my second line. So my second line is going to be from -1, -2 to -3, -4. Let's change that, -3, +4. And again, I find it helpful to call this one P1 and call this guy P2 and to call this coordinate X1 and this one Y1 and this coordinate X2 and this coordinate Y2. And then I can find the slope by the difference in the Y coordinates, which is essentially what the rise is, divided by the difference in the X coordinates. That's basically what the run is. And so it's going to be 4 take away that guy. So 4 take away -2 and -3 take away that guy. So -3 take away -1. Right. 4 add 2 gets you 6. -3 add 1 gets you -2. And you divide and you get -3. And I'm going to call this guy M2. And the question was, are these two lines parallel? Well, if you look, it's pretty obvious that they're not the same slope. So they are not parallel. So in your homework, you have a yes and a no choice. And since they are not parallel, that's the one that you would pick. And we have quite a lot of questions that are of this type, where they give you a pair of points for the first line, another pair of points for the second line, and you're being asked, is the line joining these 2 points parallel, or maybe next one it'll be perpendicular to this pair of points. So let me see if I can find a perpendicular version of that. And it didn't take long, so here's an example. The first pair of points is -3, 2 joined to the point for -1. And then the other pair of points is 1, 3. And it's going to join to -2, -4. And to remind myself, we are being asked, are these pairs of lines perpendicular? Oops, too many letters are perpendicular. There we go. So I'll go through my usual. Call that P1, call that P2. And the slope then, difference in the y's, divided by the difference in the x's. Call that x1, y1. Call this guy x2, y2. -1 take away 2. 4 take away -3. So -1 take away 2 more is -3. 4 take away -3 is like adding it. So the answer is -3/7. And I'll call that M1. Now we kind of go through the same process for the second pair of points. So the line joining this point to that one. And we'll find its slope using this equation. Let's see what we've got. -4 subtract 3. -2 subtract 1. -4 take away 3 is -7. And -2 take away 1 is -3. So that ends up being 7/3. We'll call that M2. Now, since we're being asked to check, are they perpendicular? What we need to do is find out what M1 times M2 is equal to. And if the answer is 1, the two lines will be perpendicular. If the answer is anything else, then we will say essentially that they're not. So -3/7 times 7/3. I think that's pretty easy to do. Would you agree it's -1? So we would say, yes, it's perpendicular. So that's the one you would fill in. Well, hopefully you're getting the gist of what we're doing here. Are two lines parallel or are two lines perpendicular? And we've looked at what happens if they tell you the equations of the lines and how you would solve those. And what do you do if they give you a pair of points for the first line and a different pair of points for the second? How would you do it there? Now let's look at special cases for a little while. In particular, horizontal and vertical lines. So if I said I had the line x equals 3 and the line y equals 5, and I said, are they perpendicular? Are they parallel? And the easiest way to imagine this is that if you're called x equals 3, you're this vertical line here. And if you're called y equals 5, you're this horizontal line that goes here. And it's pretty obvious in that situation then, that if a horizontal line works with a vertical line, then the answer is going to be yes, they are perpendicular. Suppose we give you the information a little bit more disguised. Suppose I tell you it's a 0.37 to the 0.39. So that's my first point, the line joining these two. And I want to compare it to 5/2 to -4/2. That would be my second pair of points. Then I am going to go through the same process as we did here, and we'll see how we have to adapt. If I call this guy P1, I call this guy P2, then this will have x coordinate x1 and y coordinate y1. This will be x2, y2. The slope is the difference in the y's divided by the difference in the x's. And the y's, in this case, are 9 take away 7. And the x's are going to be 3 take away 3. And we get a rather weird answer. Now, if ever you have a fraction and you have 0 on the bottom, we're going to call that undefined. And undefined essentially means that our line is vertical, right? If its slope is undefined, it's a vertical line. Right, we'll move on to this one then. Call that P1, call that P2. There's the X1, Y1. Here is the X2, Y2. The formula for the slope. And 2 take away 2. And -4 take away 5. So we now get 0 over -9. That's a different situation from the one that's going on here. The zero's on the top. Well, 0 divided by any number gives you a slope of 0. So anytime you think or you encounter a slope of 0, what you're really looking at is a horizontal line. Now, would you agree that a vertical line and a horizontal line are always going to be perpendicular? So your answer to this one would be yes again. They are perpendicular. And that's how you would deal with that situation. So we're going to move on to another piece of this puzzle where we're going to find equations of lines that are either parallel or perpendicular to some other line, and they'll tell us a point that it passes through. So an example of this kind of question would be question 12. Now, we are told that we want to find the equation of a line that contains I would have said passes through, but contains is fine. That contains the point P with coordinates 2, 5 and is perpendicular to the line y equals 3/4 x plus 1. Okay. So to find the equation of a line, any line, it's helpful if I know a point on that line, which we know, and I also know the slope of that line. So let's work on getting the slope. I know the slope of this one, I'm going to call M1, is 3/4. I want to find the slope of my line. My line is perpendicular to that, so I need to find out what it is. But I do know it's perpendicular, so I can use the fact that when you are perpendicular, you are, well, you have this property that the two things multiply together, give me -1. So I know that this guy is 3/4 times the unknown should be that number. And so if I want to find what M2 is, I take -1 and I divide it by 3/4. And I know a little trick that says if you want to divide by a fraction, multiply by its reciprocal, in other words, turn upside down. And in this case, you end up with -4/3. So I pretty much have everything I need. I know the coordinates of the point, and I know its slope. So I'm just going to use y take away y1 is m x take away x1. That guy is x1, y1, and that guy there, that fraction there, is my slope. So it's going to be y subtract 5 is equal to negative 4/3 x take away 2. And then I'm just going to make it look pretty now. So distribute in the negative 4/3, and you get negative 4/3 plus 8/3. And then I'm going to add 5 to both sides. And since this is a little bit awkward to do, I'll write the calculation down, and then I'll get my calculator to do it for me. So 8/3, add 5. Hit the math button, choice number 1, and the answer I get is 23/3. So y is equal to negative 4/3 x plus 23/3. And that's you finished. So that's the equation of a line that passes through this point and is perpendicular to this line. That's the approach that you would use. And anytime you get a question that looks like this, do it the way I did this one. Do it the way I did question 12. So let's do a parallel version of it. So a parallel version might be question similar to 13. We're going to have it pass through the point 1, 2, and it's going to be parallel to, and this time they're making things a little bit harder. It's going to be parallel to that line, and it's going to be passing through that. Well, let's work on finding the slope of this line, because my line is going to be parallel to it, so its slope is going to be the same. So I'm going to subtract 3x from both sides. Then I'm going to divide both sides by 2. And I can now find the slope of this guy. And my guy, my line, M2, has the same slope as this one because it's parallel. So it's that. And I also know that it passes through that point. So I'm pretty much ready to go now. We'll use the point slope equation. Where x1 and y1 are these two, and this fella here is the slope. So it's going to be y take away 2 is equal to negative 3/2 x take away 1. Strange. And what we get next, well, we'll distribute this fella. And then we will add 2 to both sides. And if you add 2 to that guy, you're basically adding 4/2, so that's 7/2. And we are finished. So far, so good, I hope. And moving on, let's see what is the last thing that we need to deal with, because we're almost finished this session. In fact, I think we may have finished it. And we are done. So hopefully this is helpful, and I'll try and make the next video as soon as I can. Goodbye for now.